if you push a car with 1,050 kilograms with a force of 750 newtons, what is the friction force and normal force acting on the car if it experiences an acceleration of 0.06? So, same steps as before. Step 1, draw the object. Here's my car. "2021 Mr. B." Okay, there we go. It's my patented version of car. Then, once we've drawn the picture, we're going to label all the forces on it. So, it tells me that there is pushing with a force of 750, so that's an applied force. Yeah, that's definitely the Ferrari for sure. Come on, I have 5 children. What do you think I drive? Of course I drive a minivan. Yeah, you gotta have a minivan if you got that many kids. All right, and it also tells me what is friction and normal. So normal will be up. We don't know what it is, so just Fn equals question mark. Friction will be against the motion, so we don't know what it is, so just FF question mark. And it doesn't talk about gravity, but we know there has to be gravity. So I'll just write FG, and I'm going to leave that one blank for now. Okay? Step 1, done, drew the picture. Step 2, done, label the forces. Step 3, draw the direction of the acceleration. Okay, which direction is my change going to be? Well, it seems like my change is probably going to be to the right. But I don't know what it, or I do know what it is. The acceleration is 0.06. Yeah, you're right. If it's going to be a Ferrari, it needs a spoiler. There we go. Now we're really talking. Looks like it has a tail. Anyway, I'm not here for my drawings. Once we've done that, we're ready for the last step that we've talked about, which is find the net force. Now, there's one thing that we haven't... Oh my gosh, wrong colors. There we go. There's one thing that we haven't done yet. We didn't include the mass anywhere. So I'm going to include the mass by writing it on the object. If you're given a mass, just write the mass on the object. And you might be saying to yourself, Mr. B, why aren't we doing knowns and unknowns? Oh, snap, we have been doing knowns and unknowns. Look, unknown, unknown, known, 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 known. Knowns and unknowns, done. In the picture. You're welcome. Okay? All right. The next step is to find the net force. So F net equals F1 plus F2 plus whatever. Okay? F1, 750 minus F... Ooh. That's a problem. Nothing to see here. Oh, nothing to see. Okay, we got to find a different way to solve this. And there is a different way to solve this. F net equals ma. Newton's second law. So let's go back and let's try this again this time. But let's do Newton's second law. So F net equals ma. The mass is 1050. A is 0.06. When I do that, I get 63 for the net force. And now we're ready to do the last step. Solve for gravity if necessary. We're going to actually come back to that. And find the missing force or forces. So what are the missing forces? Friction and normal. Okay, so how do I find friction? Well, now we're ready to go back to this stuff. Now we're ready to actually try that again. So F net and I should probably write what equation I actually used here. Force 1 plus force 2 plus force whatever. Okay? The net force is 63. F1 is 750 minus friction. Add friction to the other side. Subtract 63. Long story short, 687. Okay. Last thing, though, is it wants to know the normal force. So I'm going to do the same thing. Okay? I'm going to do the same thing, but I'm going to need the normal force. Okay? F net. Now I'm going to do it for the y direction. This was for the x. Equals F1, which is normal, minus Fg. Well, I don't know what Fg is. Now, before I hang my head and cry and run away and are sad, here's how we find Fg. Fg is mass times 9.8. So all I have to do is solve for gravity, mass times 9.8. Now, I probably need to know what the net force is. Well, it was 63 to the right, which means my net force in the y is 0. So 1050 times 9.8. Yep. Questions for me? 10,000. Things got out of hand very quickly. All right. Let's look at 4. I'm going to go through 4 a little bit quicker on the beginning part. And then I'm going to show you how to do the second part for number 4. So, same thing here. Cyclist. Now, you may say that you don't see a lot of bikes that look like this. But I think that's just you. I see a lot of boxes that look like bikes and bikes that look like boxes. Maybe that's just me. Also, I can't draw a cyclist, so look, I drew a box. Okay? Speeds up from a stop by applying a force of 125 newtons. Against friction, which is 100. It's a 72 kilogram cyclist. Okay, so let's go ahead and include their mass in here. And what is her acceleration? So let's draw the acceleration on. So that'll be forward. But it doesn't tell me what it is, so I just write A equals question mark. Notice it doesn't say anything about gravity or normal force. I'm going to go ahead and draw them just in case I need them, but it doesn't mention them, so I may not actually need them. Okay, Drew the picture, done. Labeled the forces, done. Drew the acceleration, done. Find the net force. There's two ways to find it. F net equals ma, or F net equals all the forces added together. I can't do F net equals ma because I don't know what the acceleration is. So I'm going to have to do this other guy. Okay, my net force is something. F1 is 125 minus 100 in the opposite direction. My net force is 25 newtons. Now that I found my net force, I'm ready for my last step, which is find the thing I'm missing. What am I missing? I'm missing acceleration. So, if F net equals ma didn't work the first time, it will work the second time. F net is 25 equals mass times acceleration. Divide both sides by 72. .35. All right, that's what I would call a big boy, big girl problem. That is the full problem. That's what they're going to look like. You're going to have some stuff. You're going to draw it. You're going to label it. You're going to find the net force one way or another, and then you're going to find what you're missing. That's kind of what you're doing for these last couple of problems. So let's take a look at the back page of the practice now.